As the user interacts with our web-based application, we're going to have the need to store information that we either collect from the user or information about the user's interaction with the website. To store information in a database, we use the insert command. There are two forms of the insert command. Functionally, they're identical. However, the short form makes some assumptions about the values that are being inserted. Let's look at the long form first. When we want to insert data into a table, the command is insert into. Very intuitive. Insert into some table, and then within parentheses, we list the columns into which we want to insert the data. Then the keyword values, and within parentheses, a comma-separated list of the values that we want to insert into the columns that we listed in the column name list. And the values must be in the same order as the columns are listed in the column list. In the short form, we skip the column list. We say insert into some table and the keyword values, and within parentheses, a comma-separated list of the values that we want to insert. The short form insert into command assumes that the list of values provided contains a value for every column in the table, so that there is a one-to-one relationship for each of the insertable columns in the table for each of the values in the value list, and that the values are in the same order as the columns are in the table. If we want to update the value of data that already exists in the database, then we would use the update command. The update command syntax is the keyword update, some table name, the keyword set, and then pairs of column names and values. Column name equals some values separated by commas. The most important thing about an update command is to ensure that you include a where clause. Otherwise, the update command will change all of the rows in the table. The where command will specify which row or collection of rows will have their data updated. Again, if you forget the where clause in the update statement, every row in the table will be updated. It's not common practice to delete data from a database. The more common practice is to mark data as inactive. Then at some point having a job within the database system that moves inactive data to some archiving table. However, to be complete, the delete command allows us to remove data from the database. And the syntax for the delete command is the keyword delete, the keyword from, the name of the table from which you want to delete data, and then the where clause. What is the data you want to delete? What row or set of rows do you want to delete? This cannot be emphasized enough. Forgetting the where clause with either the update command or the delete command will affect the entire table. So when we say delete from some table, we must give it a condition to test which row or set of rows we want deleted from the table. To reiterate, generally, we do not delete data. We mark it as inactive so that a table would have a field, a column named active, and that column would be set to either 1 for active or 0 for inactive, and then some job would run on regular intervals on the database system to move the inactive data out of the table and into an archive. One of the issues that software developers have with database development is changing their mindset about how to work with the data. Databases are very, very efficient at working on sets of data. However, very inefficient working row by row individually on data. So we want to change our mindset as developers when we're dealing with the database so that we deal with sets of data. And when we're dealing with sets of data, we often want to get aggregate information about that data. The SQL programming language provides built-in aggregate functions for calculating these values on sets of data. So we can calculate the average of some set of data. We can count how many items are in some set of data, the maximum value, the minimum value. We can summarize the values in some set of data, and so on. These are referred to as the aggregate functions within the SQL programming language. So let's go look at some code. In this example, we'd like to demonstrate the use of the aggregate functions within select statements. In our first select statement, we're going to ask for the count of rows in a table. For this example, we're using the sales order header table. And these are the fields in the table, and we're going to be focusing on the subtotal and the tax amount fields. But first, we'd like to know how many rows are in the table. So give us a count of the number of rows in the table. Then we're going to ask for an average of the values for subtotal that are stored in the table. Then the maximum of all of those values, the minimum of those values, and then we're going to sum the tax amount. So this will represent the amount of tax that was collected for the sales listed in the orders header table. So let's run this. The first line tells us that the sales order header table has 31,465 rows of data. Within that 31,465 rows, the average value for the subtotal field is listed, then the maximum value for the subtotal field, the minimum value for the subtotal field, and then the summation of all of the values within the tax amount field. Now, this is just touching on the surface of some of the available functions that are built into the SQL language. This example demonstrates the ease of using those functions.